Hey guys, we are this week going to look at factoring when you have a leading coefficient other than 1. Okay, so this time we are going to have a number out in front of our x squared. Now sometimes when that happens, we can just factor it out, right? Like we saw some problems where we had something like 2x squared plus 4x plus 6, and then we could just factor out a 2 and have 2 and then x squared plus 2x plus 3, right? And then we could just factor from there. The ones that we're looking at today are ones where you cannot just factor out that leading coefficient. Okay, so we're going to look at a few where you have a positive leading coefficient, and then at the end we'll look at some where it's a negative number. All right, so the first one that we are going to look at is going to look like 2x squared plus 7x plus 3. All right, so you can see that we cannot just divide everything by 2, right? Because there's a 7 here, there's a 3 here. These are not divisible by 2. So we've got to do something different with this. Now, last week, you guys learned about the x method. We are still going to use the x method here, but the way that we use it has to be a little bit different. We are going to take that leading coefficient, and we are going to multiply it by the constant term. So basically we're multiplying the first term and the last term, right? 2 times 3 is going to give me 6. So since we're still using the x method, I'll go ahead and set up the x. Okay. 2 times 3 gave us 6. We are looking for two numbers that are going to multiply to make 6. Now, these two numbers still need to add to give us a positive 7. All right, so if I'm looking for two numbers that are going to multiply to make 6, but add to make 7, well, if we are multiplying to make 6, we had 1 times 6 or 2 times 3. Well, if we're also looking for a pair that's going to add to make 7, that's going to be the 1 and the 6. Okay, so I'm going to put the 1 and the 6 over here in our x. So we have our 1 and 6. Okay, this is the part where it's a little bit different, right? Because we did this whole part right here where we multiplied the 2 times 3 to get a 6. We cannot just take the 1 and the 6 and write it out as x plus 1 times x plus 6, okay? And I'm going to show you guys why we cannot just do that here. When we try to FOIL, x times x gives me x squared. X times 6 would be our 6x. Here I'd have my 1x, and here I'd have plus 6. When I combine my like terms here, I do get that 7x, but everything else in this problem is wrong, right? I have x squared plus 7x plus 6, and what we needed was 2x squared plus 7x plus 3, all right? So we're going to have to do something different here. This is not going to work for us this time. So after we're finished with the x, we're going to use the box method, okay? So sometimes you hear this whole thing referred to as the x box process. So we have our box. I'm going to set up a rectangle here. All right, now we're going to take the first term from our problem, the 2x squared, and we're going to put that in our box. Then we're going to take the last term, the positive 3, and we're going to put that in the last box. So the first term in the first box, the last term in the last box. Now the numbers that we had over here in the x, we're going to take those from the x and put them in the box. But since these each came from the x, when we put them in the box, we're going to put an x behind it. All right, so I had a 1x and I had a 6x. If they come from the x, they keep an x when they go in the box, okay? All right, so now we're going to factor the greatest common factor for each row and each column. Okay, so if I'm looking at each row first, for the top row between our 2x squared and our 1x, the only thing that these have in common is an x. Oh, let me get a marker that works. Okay. For the bottom row, right, we have a 6x and we have a 3. So they do not have an x in common, right? But they are both divisible by 3. So we're going to factor out an x and a 3. Across the top, right, across to each column, for the first column, 2x squared and 6x, they both have an x, right? So we can factor that out. But then they also are both divisible by 2. So let's factor out a 2x. All right, and then in our last column, we've got 1x and we've got 3. Well, we can't factor out an x, right, since they don't have an x. 1 and 3 are both divisible by 1, right? So that's the greatest common factor. Okay, so our factors for the 2x squared plus 7x plus 3 come from the top and the side of our box. We would have 2x plus 1, right? 2x plus 1 times x plus 3. Okay, and if we did FOIL this one, we would see that we end up with the 2x squared plus 7x plus 3, right? Because if we do the 2x, sorry, I bumped it. Okay, if I do the 2x times x, there's our 2x squared. 2x times 3 gives me the plus 6x. 1 times x is 1x. 1 times 3 is 3. And when we combine like terms, that's where we get our 2x squared plus 7x plus 3. Okay, so we know that we had the correct answer there. All right, we're going to look at one or two more. All right, so on this next one, we are going to look at 8x squared minus 18x minus 5. All right, so if I've got 8x squared minus 18x minus 5, again, we cannot just factor out the 8. That's always the first thing that we want to check for, but neither of these numbers are divisible by 8, so that's not going to work here. All right, so we're going to take the 8, and we are going to multiply it by the negative 5. So 8 times negative 5 gives me negative 40. All right, so in our x, I'm going to put negative 40 on top. We need to put the negative 18 on the bottom. So I'm looking for a pair of numbers that's going to multiply to make negative 40 and add to make negative 18. Okay, so if I am looking for a pair of numbers to multiply to make negative 40, okay, so I could use 1 and 40, right? One of those numbers would have to be negative, 1 and positive. 2 and 20, 4 and 10, 5 and 8, 6, 7, and we're back at 8. Okay, so these are our options, right? We just know that one number has to be negative and one number has to be positive. So to combine to make the negative 18, well, the only pair that's going to combine to make a negative 18 would be the 2 and the 20. And the only way that works is if the 2 is the positive number and the 20 is the negative number, right? 2 minus 20 is where we get the negative 18. So I'm going to put the 2 and the negative 20 in the x. Now we're going to create the box. I'm going to take the first term from the problem, the 8x squared, and put that in the first box. The last term, the negative 5, goes in the last box. The two terms from the x go in the two boxes. So I have a 2x and a negative 20x. Remember, it keeps an x if it comes from the x. Okay, and then we're going to factor each row and each column. So for the top row, 8x squared and 2x, they both have x, and both numbers are divisible by 2. For the bottom row, they do not both have an x, but they are both divisible by 5. Now, since this is a negative 20 in this box, we're going to go ahead and make this 5 a negative 5. Anytime we have a factor on the outside that is touching a negative number on the inside, we go ahead and make that factor negative as well. All right, so then for our column here, we can factor out an x, and both 8 and 20 are divisible by 4. Okay, for this column, we cannot factor out an x, and 2 and 5 only have a common factor of 1. All right, so that means that our factors are going to be 4x plus 1 times 2x minus 5. Okay. All right, let's look at one more. Okay. All right, our last one is going to look like 2x squared minus 13x plus 20. All right, so when we are factoring it, let's set up the x over here. I know that I need my two numbers to multiply. I'm going to do 2 times 20. This time we want it to multiply to make a positive 40. We also need it to add to make the negative 13. All right, so I'm going to make a list of my factors for 40. Wish I hadn't erased that one from that last problem. There we go. Okay, and since we need them to be positive this time, it's a positive 40. We're trying to get numbers that are going to add to make a negative 13. Well, the only numbers that are going to add to make any kind of a 13 here are the 5 and the 8. But if I want them to add to make a negative 13, that means I need a negative 5 and a negative 8. Well, that's okay, because if I do negative 5 times negative 8, right, if I multiply those two numbers, I do get a positive 40. So negative 5 and negative 8 multiply to make positive 40, but negative 5 and negative 8 add to make negative 13. All right, so now we can set up the box. I'm going to take the first term, 2x squared, and put it in the first box. The last term, positive 20, goes in the last box. The two terms from the x go in the other two boxes, negative 5x, negative 8x. And then we're going to factor each row and each column. So for the first row, we can factor out an x, and that's it. For the bottom row, we can factor out 4. And since it's touching this negative 8x, we're going to make it a negative 4. For the first column, we can factor out an x. We can also factor out a 2. And then for the last column, we can factor out a 5. And since it's touching this negative 5x, we're going to make that a negative 5. So we have 2x minus 5 times x minus 4. All right, I hope that this video has been helpful to you. I'm going to post another video in just a moment where you have some problems that I'm going to work that have a negative coefficient. Okay, so if you're struggling with those types of problems, go ahead and jump on over to the other video. If you have other questions, please let me know how I can help. You can email me or reach out in Google Classroom. Don't forget, we'll Zoom on Wednesdays at 2:30 for any other questions.